topic, which is smart connected products for business transformation, right? So this topic will give you a strategic flavor of the different business models that the companies are framing to achieve competitive advantage. So this is a session which is an admixture of technology as well as management discipline. So I acknowledge the contribution of Parametric Technology Corporation USA and Harvard University for creating the contents in this presentation. And the topic is smart connected products for business transformation. Say, information technology has brought in a revolution in products and services. Previously composed solely of mechanical and electrical parts, products and services have become complex systems. That means an array of products serving the end customers together.
Sir, sorry to disturb you.
Yeah.
Sir, you are using laptop right now?
Yeah, I'm using laptop.
Okay. Sir, please slightly down to your screen, laptop screen, so that you will be visible properly, sir.
Is it all right now?
Right, sir. Okay, all right, sir. Thank you, sir. Thank you.
Okay. So, companies today no longer contribute based on their offering of a simple and a single product. Today, products are interconnected and we see combination of hardware, sensors, data storage devices, microprocessors, software, and connectivity tools embedded inside the products in a number of ways. Once again, smart connected products is a combination of hardware, sensors, data storage devices, microprocessors, software, and connectivity tools inside products. And these products are connected to each other. And the companies, they offer a complex systems of all these products together. And that is why the competition is based on different and new business models. And we'll talk about those kinds of business transformation, the new strategic moves that will help companies to survive in the near future. These smart connected products, which are basically an extension of Internet of Things, now offer more opportunities for new functionality, greater reliability, higher product utilization, and capabilities that cut across traditional product boundaries. As I had mentioned earlier, under such circumstances, the basis of competition among the companies who are manufacturing and delivering smart connected products has basically shifted from offering discrete single products to product systems consisting of closely related products to systems of systems that link an array of product systems together. Now I will elaborate on this array of product systems just after defining the components of the smart connected products. So basically, the evolution of products into intelligent connected devices is radically reshaping companies and the competitive landscape. The relationship a firm has with products and its customers is becoming open-ended and continuous. So basically, the smart connected products has redefined and reshaped the industry boundaries. It is substantially changing the work of virtually every function within a manufacturing or a service unit. So what is this smart connected product? Now, many of you would like to say that, sir, smart connected product is another variant of Internet of Things. But I say that there is a salient difference between Internet of Things and smart connected products. And we will discuss about that after some few deliberations. First, let me define what are smart connected products. Smart connected products have many of the same physical components that traditional products have always had. But the smart connected products have some new features embedded in them, and this is making them much more intelligent than the traditional products. Now, what are those elements that are creating that level of intelligence inside these products? They are starting from sensors and software, extending into microprocessors, connectivity, and things like that. So basically, smart connected products have three core elements. What are those three core elements? Number one, the physical components. The physical components of smart connected products comprise of the mechanical and electrical parts that are normally visible in a traditional product. Then the second component, which is the most intelligent component and heart of this kind of products, are the smart components. Now, what is there inside this definition of smart components? Smart components are the sensors, the microprocessors, the data storage devices, the control software, and the embedded operating systems like the Android operating systems and the digital user interface. These are basically the smart components which are now getting embedded in the new offerings of smart connected products. And the third component is basically called the connectivity components. The connectivity components comprise of the different ports, the antenna, the different procedures or the protocols for communication, and the networks. So these are the elements of connectivity components. So physical components plus the smart components plus the connectivity components are the three core elements of smart connected products. Mostly like the Internet of Things. But smart connected products differ from Internet of Things with respect to the analysis, the interpretation, and the managerial implications of the vast amount of data that is collected in the product cloud, which basically is one of the driving element of smart connected products. Now, slowly I will, explain to you what is product cloud, what kind of data is generated and collected in the product clouds, what are the different kinds of analysis that is being done, and how those analysis is basically helping companies to redefine and redesign the smart connected products. Now let me go slightly in more detail the explanation and the examples related to the smart connected products. Now I said that physical components is one of the core element of whether you call it smart connected products or traditional products. Now physical components comprise the product's mechanical and electrical parts. In a car, for example, the physical components include the engine block, the tires, maybe the batteries. All these make up the physical components of a car. So physical components, one of the core elements of smart connected products, are the products, mechanical and electrical parts. Then comes the smart components. The smart components basically magnify or amplify the capabilities and the value of the physical components. Connectivity, the third core component, amplifies the capabilities and value of the smart components. And this connectivity components not only amplifies the capabilities of the smart components, but also this has made it possible for their existence outside the physical product itself. So the result is a virtuous cycle of value improvement. So once again, physical components are the mechanical and the electrical parts. The smart components like sensors, software, and related elements, they amplify the capabilities and the value of the physical components. And then the third portion is a connectivity component, which not only amplifies the capabilities of the smart components, but can be made in such a way that they can exist outside the physical product itself. So, smart components, as I had already told you, comprise the sensors, the microprocessors, the data storage, the elements for controls, software, and typically an embedded operating systems and enhanced digital user interface. I had given you example of physical components in a car. And I said that the physical components in a car are the engine block, okay, the tires, the batteries. But then you might ask, sir, what are those smart components in a car? The smart components inside a car include the engine control unit, anti-lock braking system, rain sensing windshields with automated wipers, and the touchscreen displays. And in many products, the software replaces some of these hardware components, or the software enables a single physical device to perform at a variety of levels. Next come the connectivity components. The connectivity components comprise the ports, the antenna, and the protocols which enables wired or wireless connections with the product. And connectivity is very important in case of smart connected products, because through this connectivity, we can collect a lot of data related to the way these products are used by the consumers. The usage patterns can be analyzed, and improvements in the product features can be effected in the new version of the product. So connectivity is also lying at the heart of new product development. And this connectivity takes three forms. It's a one-to-one connectivity, or a one-to-many connectivity, or it may be many-to-many connectivity. One-to-one connectivity means an individual product is either connected to the user or the manufacturer, or the product may be connected to another product through a port or other user interface. For example, when a car is hooked up or connected to a diagnostic machine, that is a situation which is basically one-to-one connectivity. One-to-many connectivity. Herein, a central system is continuously or intermittently connected to many products at the same point in time. For example, many Tesla automobiles, Tesla is the company in US which are producing new design automobiles for the new era. So many Tesla automobiles are connected to a single manufacturing system. And that manufacturing system monitors performance and accomplishes remote service and feature upgrades for all those automobiles which are connected to that manufacturing system. And then there is a case of many-to-many connectivity. Multiple products connect to many other types of products, and often also to external data sources. That is basically many-to-many connectivity. Herein, for example, an array of different types of farm equipment in an agricultural domain may be connected to one another. And even they may be connected to geolocation data for coordinate control and optimization of the farm system. For example, automated tillers. Normally in Bangalore, I have seen they inject nitrogen fertilizer at precise depths and intervals, and the seeders follow, placing corn seeds directly in the fertilized soil. And soon these automated tillers will be marketed throughout India. So connectivity serves a dual purpose. First, it allows information to be exchanged between the product and its operating environment, its maker, its users, and other products and systems. Second, connectivity enables some functions of the product to exist outside the physical device. And this existence is based on what is known as the product cloud, and we will elaborate on that product cloud. For example, all of you must have heard about the Bose's new Wi-Fi system, a smartphone application running in the product cloud streams music to the system from the internet. And to achieve high levels of functionality, all these three types of connectivity may be necessary. Smart connected products are emerging across all manufacturing sectors. For example, in the field of heavy machinery, Schindler's spoke technology has reduced the elevator wait times by, say, as much as 50%. How they have done it? This is possible by predicting elevator demand patterns, calculating the fastest time to destination, and assigning the appropriate elevator to move passengers quickly. So now the question comes in, what can smart connected products do? Basically, the intelligence and the connectivity properties or the attributes enable an entirely new set of product functions and capabilities. And these product functions and capabilities can be grouped into 4 different areas. What are those 4 different areas? Monitoring, control, optimization, and autonomy. So in a summary slide, I have basically, jotted down the capabilities of smart connected products grouped into these 4 categories. Monitors, basically, this monitoring activity is achieved through sensors and external data sources, enabling the comprehensive monitoring of the product's condition, the external environment, and the product's operation and usage. Monitoring also helps to generate alerts and notifications of changes whenever there is something that deviates from the normal condition. For example, if there is any change in external environment, the system detects that and generates alert signal. Then the control is basically implemented through the software which is embedded in the product or in the product cloud, enabling control of product functions and personalization of the user experience. Then the third one is optimization, which is based on monitoring and control capabilities, plus certain algorithms or rules which help to optimize the product operation. And basically, this optimization feature enhances the performance of the product, and it is helping the predictive diagnostics services and repairs, and basically a new field in the area of analytics called product analytics is emerging on the basis of this optimization feature of the smart connected products. Then the fourth feature is basically combination of monitoring, control, and optimization. And that feature is known as autonomy. Autonomous product operation helps to diagnose the product performance without the help of anything. So self-diagnosis and service, these are the primary purpose of this feature autonomy, which we will elaborate in detail. So monitoring, control, optimization, and autonomy. Autonomy feature enables autonomous operation without the help of anybody else, self-coordination, and self-diagnosis. Any product can potentially incorporate all these four capabilities. Each capability is valuable in its own right, and each capability sets the stage for the next level. For example, monitoring capabilities are the foundation for control, optimization, and autonomy. All these three capabilities, monitoring, control, and optimization, all these three capabilities are necessary and required for enabling autonomous feature of smart connected products. So basically, a company must choose the set of capabilities that deliver its customer the value and define the competitive positioning of the firm. Now, monitoring smart connected products helps the product through its sensors to monitor its condition, operation, and external environment. Using data, a product can alert users or others to changes in circumstances or performance. I already told you that if there is any change in the operating environment of the product, this monitoring feature generates alert or alarm signals. Monitoring also allows companies and customers to track a product's operating characteristics and the history of product performance to better understand how the product is actually used. That means the behavior pattern, the usage pattern of the product by the customers are analyzed to improve the future design of the product. So that means monitoring is also helping in new product development. Monitoring also allows companies and customers to track a product's operating characteristics and history and to better understand how the product is actually used. This is very, very important. Next, with the data that is getting generated based on this monitoring and connectivity features of the smart connected products, this data has important implications for design. I said already, it helps to reduce over engineering. That means the factor of safety can be very well adjusted. This data can be used for market segmentation in a scientific manner through analysis of the patterns of usage of the products by different types of customers. And after sales service, by allowing the dispatch of the right technician with the right part, so that the first time fix rates are improved significantly. That means based on the usage pattern, the failure data is analyzed to find out what is the probability of failure of the different components. And whenever something goes wrong in the field, the companies can decide who will be the right technician for fixing this kind of problem, what kinds of part will be required, so that they can be right the first time every time. Monitoring data may also reveal warranty compliance issues and also new sales opportunities, such as the need for additional product capacity based on high utilization. In some cases, for example, in medical devices, monitoring is the core element of value creation. Meditronics, that company which measures digital blood glucose meter. So Meditronics digital blood glucose meter has a sensor inserted under the patient's skin to measure glucose levels in tissue fluid, and the connection is established wirelessly to a device that alerts patients and clinicians up to 30 minutes before a patient reaches a threshold blood glucose level, enabling appropriate therapeutic adjustments. See how vital. Control. Smart connected products can be controlled through remote commands or algorithms. And these remote commands or algorithms are built into the device, or they may reside in a product cloud. Algorithms are basically rules that direct the product to respond to specified changes in its condition or environment. For example, the programming based on this rule can be embedded in the product. For example, if pressure gets too high, shut off the valve. Or when traffic in a parking garage reaches a certain level, turn the overhead lighting on or off. These are examples of algorithmic rules embedded in the product by programming. Control is accomplished through the software embedded in the product or the product cloud. And this software or the data that is collected in the product cloud allows the customization of product performance to a degree that previously was not cost effective or possible. But today, the same technology has enabled the users to control and personalize their interaction with the product in many new ways, so that the usage of these products have now become very user-friendly. For example, you might have noticed that today, I went to Holland and I could find that the users can adjust their Philips light bulbs via smartphone, turning them on and off, programming them to blink red if an intruder is detected, or dimming those lights slowly at night. Doorbot is a smart connected doorbell and lock. Is allowing customers to give visitors access to the home remotely after screening them on their smartphones. See the utilities, see the versatilities of these smart connected products. And this rich flow of this monitoring data from the smart connected products, coupled with the ability to control product operation, is allowing companies to optimize the performance of these products in numerous ways, many of which have not been previously possible. Smart connected products can now apply algorithms and analytics to in-house or historical data to dramatically improve the output, the utilization, and the efficiency. For example, in wind turbines, a local microcontroller can adjust each blade on every revolution to capture maximum wind energy. Real-time monitoring data on product condition and product control capability is enabling firms to optimize service by performing preventive maintenance when the failure is imminent. It is helping them to accomplish repairs remotely, and thereby it is helping companies to reduce product downtime and the need to dispatch repair personnel. Even when on-site repair is required, based on the analysis of the data that is collected in the product cloud, advanced information about what is broken, which parts are needed, and how to accomplish the repair, that means the fix, how to reduce the service cost, and all these have helped companies to improve the first time fix rates. Right every time the first time. Some banks, for example, monitors many of its automated teller machines for early signs of trouble. After assessing a malfunctioning ATM status, the machine can be repaired remotely if possible, or the company deploys a technician who is given a detailed diagnosis of the problem, a recommended repair process, and often the needed parts. So it becomes very easy for the technician to set things right, and the total elapsed time for repairing the machine is as minimum as possible. Finally, like many smart connected products, the bank's ATMs can be updated when they are due for feature enhancements, and this is automatically done based on the data that we have collected. And these feature enhancements can occur remotely via software. Autonomy. When we talk about autonomous product operations, it is based on monitoring, control, and optimization capabilities that act as foundations and combine to allow smart connected products to achieve a previously unattainable level of autonomy. For example, today, at the simplest level, autonomous product operation in USA is a iRobot Roomba, the basically vacuum cleaner that uses sensors and software to scan and clean floors in rooms with different layouts. More sophisticated products are able to learn about their environment, self-diagnose their own service needs, and adapt to users' preferences. Autonomy not only can reduce the need for operators, but can improve safety in dangerous environments and facilitate operation in remote locations. Autonomous products can also act in coordination with other products and systems. The value of these capabilities can grow exponentially as more and more products become connected. For example, the energy efficiency of the electric grid increases as more smart meters are connected, allowing the utility to gain insight into and respond to demand patterns over time. Ultimately, the products can function with complete autonomy, applying various rules and algorithms that utilize the data collected in the product cloud, and this data is all about the performance of the product and the operating environment under which the product operates, including the activity of other products in the system. All this has helped smart connected products leverage their ability to communicate with other products and create an environment that is not only user-friendly, but also cost-effective in every possible way. So, these new data resources, the type of data collected in the product cloud, is basically reshaping the entire value chain. In the past, the data was generated primarily by internal operations, information gathered from surveys, research, and other external sources. But today, new sources of data are being supplemented by the product itself. Data now stands on equal footing with people, technology, and capital as a core asset of the corporation. And that's why data analytics as a profession has become so important. the value of data or the new data resources, I should say, is increasing exponentially when one type of data is integrated with other data sources. So, smart connected products, when we talk about business transformation, they're raising new questions as to how the amount of new and sensitive data that gets generated is utilized and managed. This is the first thing. How relationships with the traditional business partners, such as the channel partners, are getting redefined, and what role companies should play as industry boundaries are reshaped and expanded. And because the companies are able to find answers to these questions, there lies a significant difference between smart connected products and Internet of Things, although the basic architecture remains the same for both. The phrase Internet of Things has arisen to reflect the growing number of smart connected products and highlight the new opportunities that they can represent. Yet, this particular phrase IoT is not very helpful in understanding the phenomenon connected with the smart connected products. And that is why I am presenting to you this particular topic. Basically because what makes smart connected products fundamentally different is not the internet, but the changing nature of the products, the things. It is the expanded capabilities of the smart connected products and the data that gets generated. And these are basically giving rise to a new era of competition. This new era of competition means total business transformation, calling for devising new strategies and rules of the game for growth, survival, and achieve competitive advantage. You see, the first wave of information technology during the 1960s and 70s automated individual activities in the value chain. And this automation boundaries were from order processing and bill paying to computer-aided design and manufacturing resource planning, MRP. The productivity of activities dramatically increased in part because huge amounts of new data could be captured and analyzed in each activity. This led to the standardization of processes across companies and raised a dilemma for companies about how to capture information technologies' operational benefits while maintaining distinctive long-term plans. The rise of the internet with its inexpensive and ubiquitous connectivity opened up the second wave of IT-driven transformation in the 1980s and 1990s. And that enabled coordination and integration across individual activities with outside suppliers, channel partners, customers, and across geography. And it allowed firms to closely integrate globally distributed supply chains. Now, these first two waves, IT waves, gave rise to huge productivity gains and growth across the economy. But see, while the value chain was getting transformed, the products themselves were largely unaffected. Now, in the third wave, information technology is becoming an integral part of the product itself. I've already said that embedded sensors, processors, software, and connectivity in products means, in effect, computers are being put inside products. In addition, producing these new smart products is reshaping the value chain. Why? Because it is forcing the companies to change the design of the products, to invent new ways in marketing this product by uncovering the implicit needs of the users, relating the product features one by one to these implicit needs, and making the users understand the need payoff by buying this kind of products. This smart connected products is reshaping the value chain in terms of manufacturing factories to alter their manufacturing processes, to standardize the operating conditions, and change the mode of after-sales service by creating the new need for new activities and giving birth to new generation of subjects like product data analytics and security. The third wave of this information technology-driven transformation thus has the potential to be the biggest, yet triggering even more innovation, productivity gains, and economic growth than the previous two IT innovations. At the most fundamental level, okay, when you try to analyze and chart the impact of these products on the competitive environment the companies are facing, companies now must ask four questions. How does the move to smart connected products is affecting the structure of the industry and industry boundaries? How do smart connected products affect the configuration of the value chain or the set of activities required to compete? What new types of strategic choices will smart connected products require companies to achieve competitive advantage? And what are the organizational implications of embracing these new types of products and the challenges that affect implementation success? So these are the four fundamental questions every company has to answer if they want to survive and grow in this new era. And why now? Why we are raising these questions now at this point in time? Because an array of innovations across the technology landscape have emerged and converged to make smart connected products technically and economically feasible, because this was not possible earlier. And this includes breakthroughs in the performance, miniaturization, energy efficiency of sensors and batteries, highly compact components, low-cost computer processing power, and data storage. All of this make it feasible to put computers inside products to enable cheap connectivity ports and ubiquitous low-cost wireless connectivity. All these have made it possible to deploy tools that enable rapid software development. This is enabling big data analytics and the new IPv6 internet registration system that support greater security, simplify hands-off as devices move across networks, and it is allowing devices to request address in an automatic manner without the need for IT support. So smart connected products require that companies build an entirely new technology infrastructure consisting of a series of layers known as a technology stack. And in our next session, we will start with this new technology stack. I'll explain to you the structure and the architecture of the smart connected products. So we'll give a break for 10 minutes and then start again maybe after 10 minutes. Okay? Is it all right to all of you? Hello? Hello?
Yes, sir.
Can I give a break for 10 minutes? Am I audible? Can I give a break for 10 minutes?
Yes, sir, no problem.
Okay. And is it understandable whatever I am deliberating?
Yes, sir.
Okay. Thank you. Other than that, Corona thing is becoming problematic. Very. No problem. I have given a break for 10 minutes. No problem.
This area, no, not problem. This area, no problem. Chennai city is not Chennai. Yes. All.
Okay, dear participants, I have floated the feedback link for this session. This is the fifth session of this TTP. So kindly fill this form.
Can we start? Hello? Can we start?
Yes,
Can we
yes, sir. We can proceed, sir. We can
Yeah.
proceed.
So, I said that a new product architecture based on a technology stack is required for this smart connected products to operate. Now I will explain you this new technology stack. See, at the bottom layer, we have the physical product, and this physical product basically consists of two layers: the product hardware and the product software. The product hardware consists of the embedded sensors, the processors, microprocessors, connectivity port, antenna that supplement the traditional mechanical and electrical components. That means the traditional mechanical electrical components will be there, plus you have the embedded sensors, processors, and connectivity ports that make this entire product hardware. Upon this product hardware, the layer is the product software. And you can see from the slide that the product software is basically the embedded operating system, the onboard software applications, the connected user interfaces, and the product control components. So this product hardware and product software together is basically making this layer which is known as the product. This product is connected to the product cloud through this intermittent layer called connectivity, which is nothing but the network communication, the procedures that enable communication between the product and the product cloud at the top. The product cloud basically comprises of the product database at the lowest level. What is this product database? It's a big data database system that enables aggregation, normalization, and management of real-time and historical product data. You see this term big data, large volume with high velocity, lot of varieties of data, and veracity. It's 4 V's of big data. An analysis of that is required, giving rise to big data analytics, which is at the core of smart connected products. Upon this product data database, there is an application platform. Application platform consists of the application development and execution environment, and this is enabling the rapid creation of smart connected business applications utilizing the access to the data, virtualization, and runtime tools. Upon this application platform, there lies the rules and analytics engine based on algorithms, the rules, business logic, and big data analysis. All this is helping product operation and review, uncover, discover new insights related to the use of this product. And just upon this rules and analytics engine, that layer, the top layer is basically the smart product applications. And the smart product applications are nothing but different software programs or software applications that run on remote servers and manage all these four characteristics of smart connected products, like the monitoring, control, optimization, and autonomous operation of product functions. And this product cloud is enabled with tools that provide adequate security in terms of user authentication and system access, as well as secure the product connectivity and product cloud layers. So identity and security is another important operating environment. And there is a gateway for information access from external sources. External sources means data related to weather, traffic, connectivity and energy prices, social media and geomapping. All these have impact on the capabilities of the product. And these products are integrated with business systems. So that means the technology stack consists of the modified hardware, software applications, and an operating system embedded in the product itself. I told you that is the hardware layer. There is a network communication layer in the middle to support connectivity, and the product cloud structure at the top containing the product data database. This is the platform for building software applications, rules engine and analytics platform. And this architecture needs to be exploited across all layers through an identity and security structure. I said that this identity and security structure is very, very important enabler. And there is a gateway for accessing external data. This is the gateway for accessing external data. And there are tools that connect the data that is generated and integrated with other business systems through ERP and CRM. This technology ultimately is reducing the time for generating new product applications. And this has enabled smart connected products to share potentially huge amount of longitudinal data generated inside and outside the products, which we could not have thought before. Building and supporting the technology stack for smart connected products requires substantial investment and a range of new skills. For example, software development, systems engineering, data analytics, and online security expertise. And these are rarely found in manufacturing companies, because in manufacturing companies, mostly we will find mechanical engineers, electrical engineers. But today, if the companies, they want to build smart connected products, the HR department of these companies have to rethink the way they do the recruitment. They have to recruit young people with new skills, interdisciplinary skills, comprising of all this software development, systems engineering, data analytics, and online security expertise. They have to train and develop the existing employees who are basically mechanical and electrical engineers in understanding the importance of these functions related to software development, systems engineering, data analytics, and online security expertise. Many of these mechanical and electrical engineers, based on their own capabilities, can develop competence in these areas. But the challenge lies for the HR department to also recruit and augment the competence and capabilities of the organization in terms of recruiting new people having new knowledges in this area. So, basically, we started this discussion with trying to generate the scenario of business transformation arising out of the impact of the smart connected products and how the competitive landscape for different manufacturing industries are changing. Now, those of you who have done certain strategy management courses, who have done some strategic analysis, they will appreciate that in any industry, competition is driven by 5 competitive forces. What are they? The bargaining power of buyers, the nature and intensity of the rivalry among existing competitors, the threat of new entrants, all those new entrants, what in this particular field, what are the threats for them, the threat of substitute products or services, and the bargaining power of suppliers. Now we will take up each of these items one by one and analyze the scenario with respect to smart connected products. And you see the composition and the strength of these forces collectively will determine the nature of industry competition and the average profitability for existing competitors. The structure of the industry changes when new technology, customer needs, or other factors shift those 5 forces what we have just discussed. Let's look at the bargaining power of buyers. You see, the smart connected products dramatically expand opportunities for product differentiation, moving the competition away from price alone. Previously, products and the manufacturer of these products, they used to compete based on price. But today, knowing how customers actually use the products enhances a company's ability to group customers, to segment customers, and customize products based on the needs of those segments, and set prices to better capture value and extend the value-added services. Smart connected products today allow companies to develop much closer customer relationships. Through capturing rich historical and product usage data, the cost for a buyer to switch to a new supplier will increase. So that thing have to be kept in mind, that the manufacturers will get some advantage under such a scenario, that if we can analyze the way the products are used and incorporate those kind of features which are needed by the customers, it will not be very easy for our buyer or customers to switch from one supplier to another supplier, because by changing to other supplier, he may not get all the features that we have provided. In addition, smart connected products allow firms to reduce their dependency on distribution or service partners. And even they can do away with this, intermediaries. If you get rid of these intermediaries, those agents in between, it will help you to capture more profit. Now let us look at the rivalry among competitors. Smart connected products have the potential to shift rivalry. Thereby, it will help you to open up new avenues, lot of new avenues for differentiation, product differentiation, and value-added services. These products will enable firms to customize or to tailor their offerings to more specific segments of the market, and even customize products for individual customers, further enhancing differentiation and price realization. Smart connected products also create opportunities to broaden, to widen the value proposition beyond products per se, to include valuable data and enhanced service offering. This is very important. Offsetting this shift in rivalry away from price is the migration of the cost structure of smart connected products towards higher fixed costs and lower variable costs. Why higher fixed costs? Because of the higher upfront costs of software development, more complex product design, and high fixed costs of developing and deploying the technology stack, including reliable connectivity, robust data storage, analytics, and security. So the ultimate thing is that the fixed cost related to the manufacturing of the smart connected products is very high. And that is why whenever a new company is trying to enter this field, this high fixed cost becomes a barrier, becomes an obstacle for its smooth entry into this market. Industries with high fixed cost structures are vulnerable to price pressures because these firms need to spread or distribute their fixed costs across a large number of units sold. And until and unless that is done, they will not survive. And hence, the rivalry among competitors becomes very tense. An intense competition is there for selling their products. The huge expansion of the capabilities of the smart connected products may also force companies to get into a feature and function arms race with rivals, because they might, oh, my competitor is giving this feature, so let me give. Or my competitor is not providing with this feature, so why should I, incorporate that feature and increase my cost? So, depending on the features provided by the competitors, a firm may give away too much of the improved product performance just to save cost and increase profitability. This is another thing that needs to be kept in mind. Finally, rivalry among competitors can also increase as smart connected products become a part of the broader product systems. For example, manufacturers of home lighting, audio-visual entertainment equipment, and climate control systems have not historically competed with one another. Yet, each of them is now vying for a place in the emerging connected home that integrates and adds intelligence to a wide array of products in the home. Threat of new entrants. New entrants in a smart connected world face significant new obstacles, starting with the high fixed costs of more complex product design, embedded technology, and the multiple layers of the new IT infrastructure. Barriers to entry increase or arise when agile incumbents means those who are the existing players in this industry, capture critical first mover advantages by collecting and accumulating product data and using it to improve products and services to redefine after-sale service. Smart connected products can increase the loyalty of the buyers and switching costs, further raising barriers to entry. Smart connected products can offer superior performance, customization, and customer value relative to traditional substitute products, reducing substitution threats and improve industry growth and profitability. However, in many industries, smart connected products create new types of substitution threats. For example, wider product capabilities that include conventional products. New business models enabled by smart connected products can create a substitute for product ownership, reducing overall demand for a product. Today, people are talking about product as a service business models. This product as a service business models allow users to have full access to a product, but pay only for the amount of product they use. A variation of product as a service is a shared usage model. Zipcar, for example, provides customers with real-time access to vehicles when and where they need them. This substitutes for car ownership has led traditional automakers to enter the car sharing market with offerings from GM, from BMW, from Toyota. So these offerings are today available in US, but very soon it will come to India. Another example is the shared bike systems, which are springing up in more and more cities. All of you must have been now familiar, or at least must have heard about the shared bike systems. What happens? A smartphone application shows the user the location of the docking stations where bikes can be picked up and returned. Users are monitored and charged for the amount of time they use the bikes. Even in our IIT Kharagpur, the shared bike systems have been deployed. Smart connected products are shaking up the traditional supplier relationships and redistributing the bargaining power of suppliers. As the smart and connectivity components of products deliver more value relative to physical components, the physical components can be commoditized, or even replaced by software over time. The software also reduces the need for physical tailoring, and hence the number of physical components can vary with different varieties. The importance of traditional suppliers to total product cost will often decline, and their bargaining power may fail. However, sometimes the smart connected products often introduce powerful new suppliers that manufacturers have never needed before. For example, providers of sensors, software, connectivity, embedded operating systems, data storage, analytics, and other parts of the technology stack. Sometimes suppliers or providers of all these, they have much more bargaining power as compared to the original manufacturer. For example, with respect to, the automotive field, compared to automotive manufacturing companies, today some suppliers or providers like Google, Apple, and AT&T, who are giants in their own industries, their importance is much more. They have talent and capabilities that most manufacturing companies have not historically needed. But these talent and capabilities are now becoming essential for product differentiation and optimize their cost. So these suppliers like Google, Apple, AT&T have become very powerful and their bargaining powers have gone up. The bargaining power of these new suppliers can be high, allowing them to capture a bigger share of overall product value and reduce manufacturers' profitability. New suppliers of the technology stack for smart connected products may also gain greater leverage advantage given their relationships with end users and access to product usage data. For example, as suppliers capture product usage data from end users, they can also provide new services to them. For example, the way General Electric has done it with Alitalia. Shift in the basis of competition. So, the basis of competition is now shifting from the functionality of a discrete product to the performance of the broader product system in which a firm is just one actor. The manufacturer can now offer a package of connected equipments and related services that optimize the overall results. That is the new basis for competition, that the manufacturer will offer a package of connected equipments and related services which will optimize the overall results. And you see, to achieve this competitive advantage, a company must be able to differentiate itself and thus command a price premium. And the company must operate at a lower cost than its rivals or competitors or both. And this will allow for superior profitability and growth relative to the industry average. Now, the foundation for this competitive advantage is operational effectiveness. Now, this operational effectiveness requires embracing best practices across the product value chain. And not only embracing best practices, this has to be deployed using up-to-date product technologies, the latest production equipment, and the state-of-the-art sales force methods. Today, IT solutions and supply chain management approaches need to be modified, keeping in line with the current needs. That is a very important attribute of operational effectiveness. But the fallacy is this, that if a company is not operationally effective, and if the company does not continually embraces new best practices, on one hand, it will fall behind rivals or competitors in terms of cost and quality. But yet, operational effectiveness is rarely a source of sustainable competitive advantage. Mind the term sustainable competitive advantage, because in the long run, competitors will implement the same best practices and catch up with you. So, what is the solution? Companies need to move beyond operational effectiveness. What the company needs to do? A company must define a distinctive, that means a unique positioning of its products in the long term. Because operational effectiveness is about doing things well. So every company will do it in the long run. But what makes a company different from others is based on the strategic positioning. How do they position their product? What products are offered to which segments in the long run? That how the company positions it differently will make it different from others. A company must choose how it will deliver unique products with unique value to the set of customers. That is the segment in which the company has decided to play. So they have to devise the strategy. And this strategy requires making compromises, trade-offs, deciding not only what to do, but what not to do. Now let us discuss about these competitive advantages with respect to certain parameters. For example, design. Smart connected products require a whole set of new design principles, such as designs that achieve hardware standardization through software-based customization. See, hardware standardization will be achieved through software applications based on the customer's needs. Design principles will enable personalization. The new design principles calls for incorporating the ability to support ongoing product upgrades. And it will call for designs which will enable predictive, enhanced, or remote service. Product development processes will also need to accommodate more late stage and post-purchase design changes very quickly and in an efficient manner. Companies will need to synchronize the very different clock speeds of hardware and software development. After sales service, as I had already discussed, that smart connected products offer major improvements in predictive maintenance and service productivity. New service organization structures and delivery processes are required to take advantage of product data that can reveal existing and future problems and enable companies to make timely and sometimes remote repairs. Real-time product usage and performance data allows substantial reductions in field service dispatch costs and major efficiencies in spare parts inventory control. Early warnings about impending failure of parts or components based on the analysis of data can reduce breakdowns and allow more efficient scheduling of the services. Data on product usage and performance can feed insights, uncover product performance insights back to design of products so that firms can reduce future product failures and associated service required. Product usage data can also be used to validate warranty claims and identify warranty agreement violations. In some cases, firms can decrease service costs by replacing physical parts with software parts. For example, glass cockpit LCD displays in modern aircraft can be repaired or upgraded via software, and these have replaced electrical and mechanical dials and gauges. Product usage data also enables firms to better design for service. That is, reduce the complexity or placement of parts that are prone to failure in order to simplify repairs. All these opportunities change the service activities in the value chain substantially. Marketing. Smart connected products allow companies to form new kinds of relationships with customers, requiring new marketing practices and skill sets. As companies analyze product usage data, they gain new insights into how products create value for customers, allowing better positioning of offerings and more effective communication of product value to customers. Using data analytics tools, firms can segment their markets in more sophisticated ways, tailor product and services bundling together like a package that delivers greater value to each group of customers, and price these bundles or packages to capture more.
चतुर आंसर बोल रहे हैं। मजबूर हो गए, कॉलेज बंद कर दिया वहाँ।
Okay, dear participants, I think there is some technical issue from our expert side. So kindly be with us. Okay, sir. Now you are visible, sir. Sir, please unmute yourself. Dr. Kunal, sir, you are visible. You are in the meeting. Just unmute yourself, sir. Sir, unmute yourself.
Am I audible now?
Right, sir. Right. You are audible right now, sir.
Right. Now, just a minute. There's a lot of problems here. Yeah. Why not coming? I don't know. Anyway, see, let me not. I have given you the, PPTs. So basically, I'm not able to share it right now. So let us discuss that. See, I am almost at the end of the presentation. See, we were talking about the different aspects of design, then after sales service, marketing, and different functions. Okay. Now, basically, see, I said that the human resources function needs a lot of discussions. See, I said that the smart connected products are creating major new human resource requirements and challenges. The most urgent of this is the need to recruit new skill sets, many of which are in high demand. Engineering departments are traditionally
Okay, all dear participants, I have floated the two feedback links for both the two sessions of Dr. Kunal sir. So kindly fill both the two forms. And we have three more sessions. Currently, we have a break for 30 minutes. The next session will start at 1. I think, again, there is some technical issue from expert side. So we wait for a few minutes, sir. We wait for a few minutes. Okay, there is too much network issue from our expert side. So I just conclude the session. In this session, we have discussed so many things. We discussed about the different type of products used in the various sectors like automobiles, mobile phones, electronic devices, etc. We have learned about the data source, its importance, its collection, and different technologies where we can implement this data. We also learned about the effect on the industry structure and competition. and how it works. And that was a very wonderful session. And thank you very much for being with us. We will meet at 1 p.m. So there is a break for 40 minutes. We will meet exact at 1 p.m. for our next session. So thanks to all of you.